so this is the basic picture we're going to be using over and over in this chapter, so it's important to have a clear picture of this. One of the keys to the chapter is just labeling, making good clear pictures and labeling the parts so that we know what in our picture corresponds to what in the formulas that we need to use. Okay, so I didn't write in the right place, but obviously these two things are the slits. So these are the two slits in these two positions. So here's our two slits. Here's the light that's coming in. And remember, we're always going to assume that the light starts in phase. So at this point, the light beams are in phase and have the same amplitude, the same wavelength. We'll start with that. And they're hitting a barrier. The two light waves are hitting a barrier. So most of the light won't get through. Only the light that goes through these two slits will get through. Then it's going to travel until it hits the screen. And now we know we're not just going to get a smooth brightness on the screen. We're not just going to get a smooth brightness. Instead, we should get a pattern of bright spots and dark spots. On the screen, we should get a pattern of bright spots and dark spots because some points on the screen we'll be getting constructive interference and some points on the screen we'll be getting destructive interference. So we expect to get a whole pattern of repeating dark and light spots. So it's always a good idea to draw the center line. You want to get in the habit of always drawing the center line. So let's think about the two light waves. I guess I could call this slit A and this slit B. So would these waves at this point, at the center line, be in phase or out of phase?
In phase.
How do you know? That's right, they'd be in phase.
They started the same, now at the same distance.
That's right, so their path length difference here is 0. Since this is on the center line, their path length difference is 0. Well, this is the case where m is 0. So we know they'd be in phase. So do we get a dark spot or a bright spot?
Bright spot.
Yeah, so this is the bright spot. This is the bright spot who has m of 0. This would be called the 0th order bright spot. 0th order bright spot. By the way, when you're solving problems, they don't usually say m equals 0. They'll say it in words. They'll say 0th order, and then it's easy for people to miss that information. So it's important to look for the word order. That tells you what m is. When you see the word order, you know what to plug in for m in your formulas. Usually people just look for the numbers, and they might miss that. Okay, all right. However, if you think about it, this is the only point where the path length difference is 0. This is the only point where the path length difference is 0. If we think about these points up here on the top of the screen, which wave is traveling the longer path?
A.
Yeah, A has to go the longer distance to get here. It's clear that for anything that's on the top of the screen, A has to go the longer distance. And for anything that's on the bottom of the screen, the wave from B has to go the longer distance. So now we are going to have path length differences. And there's going to be a different path length difference for every point on the screen. There's going to be a different path length difference for every point on the screen. Well, every time the path length difference is a whole number of wavelengths, you'll get a bright spot. So this might be the first bright spot when wave A is going a distance one wavelength longer than wave B. Then we might have the next bright spot when wave A is going a distance 2 wavelengths longer than B. And then this might be when it's going 3 wavelengths longer. As long as it's going in a whole number of wavelengths, its path is a whole, as long as A's path is a whole number of wavelengths longer than B, we'll get a bright spot. And there'll be symmetrical bright spots, obviously, down below, right? Because the whole situation is symmetrical. Down here, the path distance for B would be greater than for A. Okay. So this might be the first bright spot. So what would m be for this?
1.
Yeah. And you could say m is 1 for this one down here too, I guess. Sometimes people might get technical and say it's -1, but I think it's simpler just to say that they're both m equals 1. Okay. All right, so what's the path length difference when m equals 1? Well, 1 complete wavelength. And then what would m be here?
2.
What does it mean that m is 2? It means that the wave A traveled 2 wavelengths longer in distance than wave B. So they still ended up in phase with each other, since we're assuming they started in phase. And again, how would this information be given to you on the problem? Well, they'll say something like the second order spot or the third order spot. When they say the second order spot or the first order spot, they're really telling you what m is. At least in the textbook, they use the symbol m for this. I think this is the symbol they used in your homework. I guess different things might use different symbols, but I think in this class we're just using m for this. Okay. All right, and of course, halfway between each pair of bright spots is a dim spot. Halfway between each pair of bright spots is a dim spot, and that would be given by that formula, this formula we already talked about. This is a little less important, but this is in the book. I think there might have been a homework problem about this. But anyway, every time the path length difference is equal to this expression, you're going to get a dark spot. This is a little bit tricky, actually. So, what does it mean when m is 0? For the ending outer phase. Remember that when m is 0, that means that one of the rays went half a wavelength longer than the other. When m is 0, that means one of the waves went half a wavelength longer than the other. So where would that first dark spot be here? You gotta point to it with your finger. Where would that first dark spot be? Yeah, it would be halfway between the first 2 bright spots. So all my little dots here were supposed to be bright spots. All the dots are bright spots. So maybe I'll make a little dash for the dark spot. So if we're moving up the screen from the center line, here's the first dark spot. Over here. So what's m for this dark spot? 0. This is the 0th order dark spot, and symmetrically there's a 0th order dark spot down here.
No, it's not m as a half.
Yeah, it's not m equals 1/2. There's a 1/2 in the formula, but m equals 0 here. As always, I should have drawn a bigger picture. It's always going to draw a big picture. Okay. My bright spots are leading into my dark spot. But I have these dashes for the dark spots and the dots for the bright spots. So the important thing here is, where is the 0th order? Well, how many 0th order bright spots are there?
1.
But how many 0th order dark spots are there?
2.
2. And notice also then, the 0th order bright spot is on the center line. But so the 0th order dark spot can't be on the center line. So how about the first order dark spot? Go ahead and point to the first order dark spot. Oh,
So it's between 1 and 2.
For the bright spots, yeah. So here's the first order dark spot. No, I'm sorry, yeah, that's the first order dark spot. And here's the second order dark spot. So these are the m's for the bright spots, and on the left I'm writing the m's for the dark spots. All right, so let's see how this could be made into a trap. Let's talk about the first bright spot below the center. For the first bright spot below the center, what would m be?
First bright spot below the center, m is 1.
Right. But now let's think about the first dark spot below the center. What would m be for that?
0.
So notice that the first dark spot is a 0th order. So it's easy to make traps about this in problems. So I did see one of the homework problems that had this trap in it. If they ask you for the first dark spot, that doesn't mean m is 0. The first dark spot is the first dark spot below the center. Maybe I misspoke. So if they ask you for the first dark spot, that doesn't mean that m is 1. It means that m is actually 0. And there was a homework problem that had that trap. So the first dark spot is 0th order. But the first bright spot is first order. So the bright spots are easier to work with over here.